Hello everyone, so this video is going to be covering the interconversion of hexoses. So after going through the pentose phosphate pathway, we ended up with a couple fructose 6-phosphates. And as I mentioned, you can put them into glycolysis, you can turn them into glucoses, and this is sort of just the pathways describing how that happens. So you can take fructose and you can phosphorylate it, and you can get a fructose bisphosphate. And if you recall from, I'm just going to put P2 for bisphosphate. If you recall from glycolysis, this is directly out of glycolysis. So we use an aldolase here, and we get, essentially after a couple other recombination steps, we get two glyceraldehyde 3-phosphates. And then finally, we're going to turn them into pyruvate. So this is straight up glycolysis. And so what enzymes are responsible for that? Well, phosphofructokinase for the phosphorylation of fructose. To split the fructose bisphosphate into two groups, you need an aldolase. So you need a phosphofructose, which I'm going to abbreviate as P.F, phosphofructose aldolase. And there's actually two different ones that can do this. So this becomes more relevant in a little bit, as I'll explain. So A or B. And then finally, we're not even going to worry about how to get to pyruvate because you guys know glycolysis. But we can also just get rid of that phosphate altogether and just end up with fructose. And we can then use a fructokinase to simply phosphorylate the single fructose, so fructose kinase. And this will give us a different configuration of fructose. This will actually give us a fructose 1-phosphate instead of a 6-phosphate. And then we can actually use an aldolase on that to yield us a glyceraldehyde, not a phosphorylated one per se. But we can actually take this glyceraldehyde and convert it over to the glycolysis chain. Now, the whole reason we bring this up is because there are two distinct steps here where something bad can happen. Now, in this first step, if somebody is born without fructokinase, or simply doesn't have enough because fructokinase is found in the liver, so maybe if you have liver damage, then you will have fructoseuria, and that just simply means that you'll have fructose in your urine. And this is actually a completely benign condition. So there's literally no other symptoms other than finding fructose in your urine, which you can only confirm via lab tests. However, if you're missing this next enzyme here, a lack of aldolase B is not benign as compared to fructoseuria. So a lack of aldolase B will cause fructosemia. And it's also known as a hereditary fructose intolerance. And fructose will build up in your blood and it can cause coma or convulsions or even death in some cases. But the treatment is fairly simple. You just have to simply avoid all fructose intake. So these are important. And as you can see here, that the lack of aldolase B would mean that we would be able to process fructose down into fructose 1P, or we could process it over this way. But because aldolase is also responsible over here for the splitting of fructose into glyceraldehyde, without the aldolase B, we would have a buildup of fructose, which is why it ends up in our blood. Now, to this left here, this is where we're converting over into glucose. So we can take a fructose 6P and change it into glucose 6P. So this is sort of the undoing of the glycolysis pathway. But it's important that we have these steps. So fructose can change to glucose using phosphohexose isomerase. And then we can take our glucose 6P and change it into a glucose 1P. And you'll see how this pathway becomes relevant in a little bit as we get near the bottom. So this is a 1P, glucose 1-phosphate. And we simply use a phosphoglucomutase to do this step. Now, this next step, we add a molecule known as UTP into the picture, uridine triphosphate. Now, when we attach a uridine triphosphate to glucose, we get UDP glucose. And what's interesting about UDP glucose is that it can be used to detoxify parts of our body. So what happens is we take UDP glucose and turn it into UDP glucuronic acid. And glucuronic acid, UDP glucuronic acid, will bind to toxic elements in our body and form a gluconeuride, which can be excreted. And this renders toxic elements in our body inert because we can just bind it and get rid of it rather than it building up and harming us in some way. Now, if we don't utilize it to detoxify our body, we can simply get rid of the UDP here using water and we end up with glucuronic acid. And then there's a whole bunch of other steps that we don't have to go into detail on. But essentially what happens is that the glucuronic acid can be recombined into xylulose 5-phosphate. And if you remember from the pentose phosphate pathway, this molecule can be combined with a 4-carbon molecule. And doing this, we can come up with another fructose and we can just restart everything once again.